Hello, my name is Fiona and I'm here to tell you about my qualitative research project on knowledge construction in biomedical science education. I realize this topic may sound rather complicated, so what's the purpose? What's it all about? First, knowledge construction is like how someone builds an understanding about a topic. Start with a messy soup of information from websites, books, YouTube, and arrive at an understanding of the topic. This is important in biomedical science in order for health professionals to interpret new medical research and provide good care for patients. But the question then is, how can we teach students these skills of constructing knowledge? My video will follow this outline. First, I'll explain the background. Then, my own project and what I found out. Then I'll show you how the findings are relevant in science education and society. And lastly, the ethical considerations. The most important thing to start with is the concept of knowledge construction. Constructivism is a theory of learning in which students build meaning from their experiences. So a student builds a frame of understanding about a topic. And then, when she finds new information, she adds to her frame. Or, if the information doesn't fit logically, she can change her frame. But I also wanted to investigate how to teach the skills of constructing knowledge, specifically with the CCCS instruction at Maastricht University. This stands for, brace yourselves, collaborative, contextual, constructive, and self-directed teaching. Collaborative, so working together and learning from peers. Contextual, linking the material to the real world, making it relevant. Constructive, brainstorm what you already know, sort it into a framework and add new information. And self-directed, identify what you wish to learn and find your own resources. So we've got the skill for a student to develop, being able to construct knowledge. And then we have the methods a teacher may use in the classroom, like CCCS. Pulling it all together, I was interested in these questions. How do students construct knowledge about biomedical topics? And how do CCCS teaching methods contribute to developing these skills? So I held interviews with 5 university students. Each one had studied with the CCCS teaching system. I then wrote down what they said, read it many times, and generated themes from their responses. In my findings, the first theme is students construct knowledge in biomedical topics following a cycle like this. Identify what you want to know. Search for information. Using websites, books, research articles, videos, ChatGPT. Evaluate the sources and the information within based on how useful they are to you. Connect concepts, pull out the big ideas, and come up with new insights. And this cycle repeats because after round 1, you might realize you have another question to search for and improve your understanding. The second theme was about how CCCS teaching methods might help or hinder learning this cycle. So, students learn the knowledge construction process by trying it, like learning by doing. Going back one step, if you learn something by doing it, well, you'll only do it if you have the motivation and the opportunity to do so. This is how CCCS instruction helped. For instance, being able to pursue their interests and collaborate with enthusiastic peers helped students want to construct knowledge. And the opportunities came from teaching methods like group discussions, individual information research, and independent projects. These things gave students the chance to practice constructing knowledge. How did CCCS hinder the process? There was the issue of a lack of guidance. Students didn't know how to pick a research question, find good sources, or organize the mess of information. This was especially hard for students just starting with the CCCS classrooms, coming from a more standard textbook instruction. In review, we've got a cycle of constructing knowledge and a teaching system that helps motivate and offer opportunities to construct knowledge. But it also has these problems of not enough guidance and a steep learning curve. So why does this matter? Consider that your doctor has to understand complex topics like diseases in order to provide care for you. There's a lot of information out there, and sometimes it's messy. Health professionals should have the skills to search for useful information, check it for accuracy, and make links in order to help you when you're sick. But also the general public should have these skills so they can understand their own health, especially in the face of misinformation. How can we teach these skills? Teachers can make assignments where students have to independently face this messy soup of information and pull clarity from it. Then, teachers can make situations where students construct knowledge together, like in a group discussion. Also, helping students stay motivated. How so? Let students explore their own interests and give students ownership so they can choose and direct their own projects. Then, make group settings and encourage students to be involved. On top of all this, some guidance can help transition from textbook learning to this open-ended knowledge construction, such as teachers can give example search questions and example source lists to help new students deal with this big information soup. Lastly, since we want to teach not only biomedical content, but also the skills of how to learn this content, both should be tested for on exams. For instance, an exam that is an independent project on a medical theme, where the student has to go through the whole search, evaluation, and organization process. Now for the ethical considerations. When conducting the interviews, informed consent was important. I wanted participants to understand the study's purpose and how their responses would be used. I also made it clear that they could withdraw consent at any time. During the interviews, I used open-ended questions to create a comfortable environment where participants could share their experiences, whatever they may be. After the interviews, confidentiality was key. I kept their personal information safe and protected their identities using codenames. At the end of the project, only anonymized data will be kept. In review, my research explored how students construct biomedical knowledge in this cycle. First, identify wanted knowledge, then search for information, evaluate it based on how useful it is for you, connect and synthesize the information into a knowledge framework. Then I looked at how they learn these skills. CCCS instruction can help by giving opportunities and motivation to practice constructing knowledge. Challenges include a lack of guidance, especially for beginners. This research highlights how we can prepare future health professionals to deal with complex and evolving medical information, and in the end, provide good patient care. Thank you for listening.